Till now, we have talked about certain aspects of formal languages and automata theory. We talked about what we are going to cover in this, and then we talked about the finite automata, a little bit of finite automata. So basically, we wanted to give you a motivation towards finite automata. But before going into the mathematical details of the finite automata or mathematical background, formally defining the finite automata. Before we do that, we want to go for the mathematical preliminaries so that the things are very clear and terminology is consistent throughout the course. So for that, let's try to start with the preliminaries. And first thing is proposition. What is a proposition? Proposition is a statement that bears a truth value. Statement with truth value. So what does that mean? So for example, a statement such that sun rises in east, sun rises in east. It has a truth value associated to it. It is true or false. Either sun rises in east or it rises in somewhere else. So you can assign a truth value to it. So currently we can assign that the truth value is true that is assigned to this statement. You can have other statements as well, which might result into a false truth value. For example, uh, moon revolves revolves around solar system. Definitely, this is false. So, although this is a proposition, the truth value to this proposition is false. So sometimes we have proposition with an argument. So for example, you consider this px is a proposition that is dependent on this x, and the proposition is x is even. So for whatever x you take in your consideration, whether that x is even or not, that particular truth value is assigned to the statement. Similarly, you can have other maybe other prepositions that takes variable. For example, x is a star, is a star. So you put in the set there may be earth. You can write so earth is a star. So this associates a truth value corresponding to false. You can consider moon to be a star, but again this proposition bears the false truth value. So these are kind of propositions. They bear the truth value. Now let's move towards another aspect or another uh, thing called set. What is a set? Set is a collection of objects. It's a collection of objects. However, we can say that these objects are they related or they are not related. So in all the useful sets means the set that can be used to solve a problem or to discuss a problem. All such problems, they have some kind of related objects. So useful sets have related objects. How they are related? They are related because of that problem. Because that problem actually utilizes all those objects, and that's how they are related. So sometimes people also say that the set is a collection of related objects. However, this relation is not defined by mathematics, but it defines or it is constrained by the problem definition and problem domain. Now, sets are how sets are written. So the notation of when we want to write the sets, we denote it within the curly braces. So you write the items within these curly braces, the opening and the closing curly brace. You can write a set. it can be written in two forms. So this form is called a list form. This is called list form, and there could be another form called set builder form. Set builder form. And what is a set builder form? Set builder form is a form wherein you provide a membership property. So how does it look like? So it looks like this one. Same set, let's say A. We want to write it in terms of set builder form. So we say that all such x's which are natural number natural number and x is less than 4. So again, this refers to the same set 1, 2, 3, but it is written in the set builder form because it provides a statement that bears a truth value. So either this px is for that particular x, it is true or it may be false. It cannot be something else. So once we say such thing, then we say that it's a the proposition that is actually identifying the membership of x. So these are sometimes are called membership property. Membership property. So for anything to lie in this particular set, for any number or any object to lie in this particular set, it has to fulfill this membership property. It has to satisfy, it has to bear a true truth value to this membership property. So for example, here 1 is a natural number and 1 is less than 4. So 1 is a part of it. 0 is not a natural number. So 0 cannot be a part of it. Uh, let's say 2 is a natural number and less than 4. So it's a part of it. 5 is a natural number, but it is not less than 4. So it cannot be a part of it. So this provides the membership property, and whenever the value comes out to be true for this particular statement, for this particular proposition, that particular number is a member of set A. That is what we want to say in this particular thing. The sets have few restrictions, that is, and or properties, you can say. Since it's a collection, so order does not matter. Order does not matter. And again, it only requires unique items. So you do not duplicate them. So for that matter, if you are considering this particular property, we say that 1, 2, 3 is equivalent to, right, equivalent to 2, 3, 1, because they do not have a difference over the order. Similarly, if you are considering unique item, so 1, 1, 2, 3, this cannot be a set, not a set. Okay, so that's about the sets. Let's move towards some of the operators and some of other things that are required or that are used with the help of sets or while we work with sets. The first thing is belongs to operator, belongs to or membership or in operator. So let's try to understand that. So for example, let's say this set A is there and you have elements 1, 2, 3. So anything that is inside this is a member of set A. So how to denote it, how to represent it? So we say that element 1 is in A or is a member of A or is belongs to A. 1 belongs to A and 5 does not belongs to A. So if you say 5 belongs to A, it is false. And 1 belongs to A, it's true. But you can also say that 5 does not belong to A, and this is true because actually 5 is not there. 5 is not a member of this particular set. So we say that by saying this particular thing, we say that 5 is not in A. So sometimes people think that sets do only contain certain type of things. So set may contain any kind of thing, any absurd looking things. So set may contain like, okay, you can say that this figure is also contained in set. Maybe you can say that this Hindi letter is also in set. Then you can say that this circle is also in set. Maybe 1, 2, 3, the numbers are also in set. So there are many things that could be inside the set, and they need not to be similar in certain way. They are related to the problem if it is a useful set. So let's talk about subsets. Subsets are certain kind of special sets for a particular set. So for example, if you are saying that set set B is a subset of A, so this is the symbol for subset. This is basically the symbol of subset, right? So when I say B is a subset of A, it means every element of B, every every element of B is in A. Every element of B is in A. So consider this one. I say that 1, 2, 3, and let's say this is let's say set A, and the set B is 1, 2. So 1 is in B, 1 is in B, 1 is in A, 2 is in B, so 2 is in A also. So all the elements that are in B are also in A, and that's why we say that B is a subset of A. So for the matter of fact, if you look at some set A, whether set A is a subset of A, so you see that okay, one is a subset, one is an element in A as well as in A. Similarly, 2 is an element of A as well as of A. 3 is also an element of A as well as of A. So in that sense, yes, A is always been a subset of A, right? So uh, such sets, such subsets are called trivial subsets. So if A is, since it is always a subset of itself, so A is a trivial subset of A. So we say that proper subset. So there is a word called proper subset. A set which is not itself, which is not itself. So it's set B is said to be proper subset of A if B is a subset of A and B is not equal to A. So B must be something smaller, something in extra. There must be something extra that is not in B but in A. But all the elements of B are in A. So in that case, we say that B is a proper subset. Proper subset. Then there is a set called null set. Null set is a set that does not contain anything. So it's also named as empty set, empty set, or void set, or it is represented by mostly 5. So null set, empty set, void set is always they are representing the same set, that is empty set, that does not contain any item. Since it does not contain any item, we say that phi is always a subset of, is always a subset of any set. There are some other specific sets, specific notations to some standard sets. So let's talk about them. One of them is the first one. These are some special sets. So basically, set of natural numbers. Set of natural numbers. So this contains numbers from 1, 2, 3, and so on and so forth. Then there is a set of whole numbers. This is a natural numbers, set of natural numbers, which also contains element 0. So these are called whole numbers. So it is actually has 0, 1, 2, and so on and so forth, all the other elements. Third one is set of integers represented by a z. So how we, or what are the elements of this set of integers? So we have 0, then plus minus 1, then plus minus 2, and so on and so forth. All these things are integers. Set of real numbers, set of real numbers. Then we have set of rational numbers, set of rational numbers. Then we can have a set which is a set of complex numbers. So these are some special sets that we are going to talk about, or we will be going to work with throughout the course. In the next lecture, we are going to talk about some of the operations on these sets. Thank you.